Good afternoon to the stakeholders of Canned Foods. My name is Hazira, and together with me are my BPE team members, Wei Ping, Min Ai, Yvette, and Daryl. Today, we'd like to present to you two innovations that we have in mind to further improve the recommendations you have provided previously. The first innovation will be further elaborated by two of my colleagues, Wei Ping and Min Ai, with regards to the technology used, impacts, benefits, the potential challenges and limitations caused by the implementation of the innovation, followed by my other two colleagues, Yvette and Daryl, who present on the second innovation in a similar manner. To refresh your memory, this is our proposed to be process. These will be the two parts of the process we'll be focusing on today. Without further ado, I'll pass the time to Wei Ping to talk about our first innovation.
Thank you, Hazira. The first process innovation idea focuses on hyper-automating the role of warehouse manager. In the modified process, there were instances of misplaced and spoiled items during checks. The warehouse manager also had to check for the actual physical stock count in the warehouse and had to decide whether there was a mismatch in inventory. To further innovate the updating and checking of inventory done by the warehouse manager, we would like to introduce 4 technologies which will be elaborated by Min Ai.
Thank you, Wei Ping. The first technology that I would like to highlight is the optical character recognition. With the OCR converting product information into QR codes, it can be easily retrieved, printed, and pasted onto products, allowing for easy accountability with regards to its location, current stock availability, and product details. By scanning the QR code, the robotic process automation will assist in matching the inventory records in WIS with the actual amount of stock in the warehouse. Should the numbers not tally, the machine learning algorithm will also make the decision to update the WIS. To reduce the chances of spoiled items, the IoT digital twinning will also be implemented, where sensors will be utilized to record the temperature of the warehouse, and if anomalies are detected, it can be handled ASAP, reducing the risk of spoiled items. As seen in the before and after process review, the tasks previously handled by WM have all been replaced by various technologies. To summarize, hyper-automation would prove to be beneficial as it prevents misplaced and missing inventory items and also reduces the chances of spoiled food items. To add on, there are many positive impacts on the changes, such as reduced resource costs and time required by the WM to perform the task. In addition, automating these tasks would also greatly reduce chances of manual error and aid in early detection of unknown errors. However, with every changes made, it is inevitable that there will be challenges faced, and some that we have identified include the huge amount of investment cost of the new technology. Another thing to highlight would be the level of employees' acceptance, as new technologies are usually met with resistance. In addition, the process will also result in increased cost and time as employees need time to adapt to the new changes. Now I'll be passing on my time to Yvette to elaborate more on the second innovation.
Thank you, Min Ai. Our second innovation involves the automating of the finding of suppliers in the RCS and SNS. Currently, upon stock check completion, WIS emails PB, who then uses RCS to retrieve data of existing suppliers who can meet delivery dates. If no such suppliers are found, PB then uses SNS to find new suppliers. Daryl will tell us more about the specific technologies we plan to use to automate this process.
Thank you, Yvette. For the second technological innovation, I would like to bring our attention to NLP, short for Natural Language Processing. NLP allows computer to analyze and process large amounts of natural language data, which might sometimes be found in, for example, emails. In the purchase requisition to purchase order sub-process, many emails are sent from individuals of different departments. NLP can be used to pass information from emails written in natural language into machine learning processing technology, so that decisions that mimic what a human would do in a given scenario can be executed. Before integrating innovative technologies, the PB had to read and process the information sent by the WM after stock check completion. With this information, they would then search for existing suppliers using the RCS, and if they are unable to find existing suppliers that meet their requirements or are willing to deliver, they would have to search for new supplier using the SNS database. After integrating NLP and ML processing, everything from email data processing to the search of existing or new suppliers can be automated. The benefits of automation include automated data extraction. The PB may not be on their email 24/7, and there might be a lag time between when the email reaches them and when they read it and carry out the necessary tasks. Thus, this would save time in the overall process. Furthermore, having ML processing would mean that data could be used more quickly, reducing time taken for this activity while also freeing up manpower, as PB no longer has a part in this process. However, when using these technologies, one has to keep in mind their limitations, which firstly includes NLP not being able to decrypt ambiguity, whether it be lexical, synthetic, or semantic. Secondly, spelling errors in emails can be inferred by the PB, but not by NLP. Both these issues will lead to a halt in the activity. Last but not least, we are not able to outsource the creation of NLP as the purchase requisition to purchase order subprocess may have very domain-specific languages. With that, we have come to the end of our presentation. Thank you for listening.